The last part of question 2 on tutorial sheet 4 asks us to redesign the sampling system because we're essentially oversampling those 3.3 kilohertz signals because we're having to sample them at 20 kilohertz so that everything's sampled equally, but we don't need to do that. So the question asks for, in the above sampling format, the low data rate inputs are sampled much more often than necessary. A narrower transmission bandwidth could be obtained, for example, by sampling the 10 kHz signals 3 times more often than the 3.3 kHz signals. Devise a new sampling scheme to achieve this and repeat the calculations of A and B. So what we're going to have in this situation is we're going to have our initial 6, and each one of those is 3.3 kilohertz. And then we've got our channels 7 and 8, which are at 10 kilohertz. And what it suggests is if we sample this at 3 times the rate, in other words, what I'm going to do is break that down into 3 sampling points, so that when my switch, which is rotating, taking samples, it's going to take a sample of channel 1, channel 2, channel 3, channel 4, channel 5, channel 6, and then rather than just sampling channel 7 once and then channel 8 once and then rotating back to channel 1, it's going to sample channel 7 3 times. So this is 7.1, 7.2, 7.3, 8.1, 8.2 and 8.3. So the switch is going to move through these and then sample there, then there, and there. So in other words, we're sampling that signal 3 times as often as we need to. And we know that we have to sample this signal at twice 10 kilohertz. So we've got to sample both these signals at 20 kilohertz. So the sampling frequency of which we're going to have to do this is going to be 20 kilohertz divided by 3. So it's asking us, it says do it 3 times faster, and if we work out what that is, so we've got 20 divided by 3, and that's equal to 6.66 recurring, so that goes on forever, which is enough in terms of these signals, because the sampling frequency for each of those, which is 3.3 times 2, is obviously equal to 6.6. So the sampling frequency, if we sample at 20 divided by 3, is enough to be able to sample each of these signals as well. So the total sampling rate now, as we're sampling at a much lower rate, is going to be 6.6. So the total sampling rate is 6.667 recurring, multiplied by the amount of times we're doing the samplings, which is 6, 7, 8, 9, 10, 11, 12. And if we do that, we get 80 kilohertz. Which is a much lower switching frequency than we had on the previous examples, which was 160 kilohertz. And well, it says we have to repeat calculations of part A and part B. Part B is asking for what is the minimum bandwidth of the low pass filter. So in the same way that we had half, if we look at the frequency spectrum, we've got signals that will look like this, spaced at the sampling frequency apart. So that's the bandwidth of the signal. So as we know that is going to be 80 kilohertz there, our low pass filter is going to be at 40 kilohertz. So our low pass filter bandwidth is equal to 40 kilohertz.